Okay, what is a proportion? A proportion is a statement saying that two ratios are equivalent. We're going to start with a unit rate to explore this idea of proportionality and what does it look like and what does it mean to us right now with what we know about rates and unit rates. So we're going to start with a unit rate, and we'll say it's the rate you earn money for babysitting a week, and we'll start with $25 in 1 week. Using that unit rate, I can find some equivalent rates, $50 for 2 weeks, and $75 for 3 weeks, and $100 for 4 weeks. And as I look at these unit rates and rates, I can find some proportional relationships, such as $25 in 1 week is proportional to $50 in 2 weeks, and $75 in 3 weeks is proportional to $100 in 4 weeks. And I can change up the combinations of any of those rates and unit rates and make a proportional statement. But what I'm going to do instead is I'm going to take those rates and I'm going to turn them into a nice, easy to read table. And in this table, I'm going to put time in one column and the earnings in the other. So in 1 week, you earn $25 babysitting. In 2 weeks, you earn $50 babysitting. In 3 weeks, you earn $75. And in 4 weeks, you earn $100 babysitting. And we know that once we have a table such as this, where I have an independent variable such as time and a dependent variable such as earnings, I can go ahead and graph that. And I did so. So now as we look at the graph, you can see that my x-axis is my time in weeks, and my y-axis is the earnings in dollars. And I've got the point $25 in 1 week, $50 in 2 weeks, $75 in 3 weeks, and $100 in 4 weeks. Notice my graph is a straight line and it starts at 0.00. Now, there's one more thing that I can do, and that is ask myself, well, how did I get from 1 to 25 in my table or in my proportional relationships in the top? How did I get from 2 to 50 or 3 to 75 or 4 to 100? And when you ask yourself that, you come up with what the rule is. And the rule is, well, if I take 1 times 25, it's going to equal 25. And 2 times 25 will equal 50. And 3 times 25 will equal 75. And 4 times 25 will equal $100. So once I've done that, I know that my rule is to find y, and I'm thinking of my function box. I have to put x of 4 perhaps into the box. Inside the function box, it gets multiplied by 25, and what comes out of the function box is my y, which is 100. And when I think of that, I then can come up with this rule, that y is equal to 25x. And before I do anything else, I'm going to go back and say, okay, what's the thing that connected all of these pieces together? Well, I started out with $25 in 1 week. Then it showed up in my table. Then it showed up in my graph. And finally, it showed up in my function rule. That's what we're going to look at now, is how to find this magic number, either in a table, a graph, or in a function rule. What I just demonstrated was direct variation, and direct variation occurs when two quantities, x and y, can follow a rule where y is equal to some number, k, times x. and k cannot be equal to 0, otherwise y and x will not vary directly. As a result of direct variation, you'll end up with a graph of an equation that passes through the point 0, 0, and it will be a straight line. And when two variables vary directly, they also vary proportionally. So they show proportionality. We're now going to look for this idea of proportionality or direct variation as it exists in tables, graphs, and in rules or equations. In order to understand this idea of proportionality, we first need to understand what this constant of proportionality is. And it is going to be represented by the letter K in the examples that follow. It is a ratio. It's a ratio of our y values to our x values. It's a ratio of our vertical to the horizontal in your graph. It's also a unit rate. And think back to our first example where I started everything with a unit rate of $25 in 1 week. And the ratio of y to x is the same for all the x and y values in a table. And we're going to look at how this constant of proportionality shows up in each of the 3 parts of a function in the tables, graphs, and in the equations. First, we'll locate the constant of proportionality in a graph. The graph represents the distance traveled by a lava flow over time. To find the speed of the lava flow, find the constant of proportionality. And for this example, our constant of proportionality will be the unit rate that we find within this graph. To find my constant of proportionality, the first thing I need to do is pick any point on the line where I can read the x and y value easily, and then calculate the unit rate. And the unit rate is going to be the ratio of my y's to my x's, and for this graph, my y values are the distance the lava traveled in miles, and the x value is the time in hours. So I'm going to pick this point here, and the y value for that point is 3 miles, and the x value is 2 hours. So when I write that ratio of 3 miles in 2 hours, that is a rate, but to find the constant of proportionality, it needs to be a unit rate. So to turn 3 miles in 2 hours into a unit rate, I divide the top and bottom by 2, and I end up with a unit rate of 1.5 miles in 1 hour. So my constant of proportionality is 1.5 miles in 1 hour. To find the constant of proportionality in a table, we're going to calculate the ratio of y to x for each set of x and y values in the table. If proportionality exists, the y to x ratio will be the same for all the values in the table. So as I look at the first example, the first table, my ratio of y to x is 2 to 1. For the next x and y value, it's 4 to 2, which simplifies to 2 to 1. The next set of y and x values is 6 to 3, which simplifies to 2 to 1. And for the next set of values, I have 8 to 4, which simplifies to 2 to 1. Because all of these simplify to 2 to 1, they have the same ratio, so the constant of proportionality is 2 to 1. Now, as I look at the second table, I'm going to again take the ratio of my y's to my x's, and I'm going to simplify. So for the first set of numbers, my first x and y values in the second table, I have the ratio of 4 to negative 2, which simplifies to 2 to negative 1. For the second one, the ratio of y to x is 1 to negative 1, which can't be simplified. For the third, it's a 1-to-1 ratio. And for the fourth, it's a 4-to-2 ratio, which simplifies to 2-to-1. Because these are all different ratios, this is not a proportional relationship. Determining proportionality for equations and rules is actually rather simple. If we go back to the beginning of the video where we talked about direct variation, and the equation for direct variation shows two numbers, y and x, such that y is equal to a number k times x, and k can't be 0, we're going to actually look for equations that look like this. And I gave an example here where y is equal to 3x. In this example, the constant of proportionality is the coefficient in the equation, which is 3. So when I look down here at some of my examples, I have y is equal to 2x. So this looks like the direct variation equation, y is equal to kx, but you can also check it by saying, well, if in this case x was 0, y would equal to 2 times 0, and 2 times 0 is 0. So y is 0 and x is 0, and if I graphed that for this equation, I would have my line going through the point 0, 0, which does show direct variation. So in this example, my k is 2, and this is a proportional relationship. In this example, it looks like the direct variation equation, and it is, and my k value is, in this case, -6. In this example, y is equal to -x. First glance, you might say, well, that's really not direct variation. It's not showing proportionality. But we know that there is a number that goes right next to that x, even though it's not shown, and that number is 1. So it really looks like this. Y is equal to -1x. And when I rewrite it like that, then it's easy to see that k is equal to -1. For our next example, this equation does not look like the direct variation equation, y is equal to kx. We have this +1 here. And because it has a +1, if I said x was equal to 0, I would have -5 times 0 plus 1 would mean y is equal to 1. So when x is 0 for this equation, y would equal 1. That means this equation will not go through the point 0, 0 on a graph, and the graph will not show direct variation either. So this one is not proportional. In the next example, y is equal to -2/3 x. Again, this looks like direct variation, and this time my constant proportionality is actually a fraction, and the fraction is -2/3. And finally, in my last example, y is equal to 8x minus 4. Again, if I replace x with 0, I would have 8 times 0 is 0. 0 minus 4 would be -4. So I would have x is 0 and y is equal to -4. And because of this -4, or adding a -4, that graph will never go through point 0, 0. So this one is also not proportional. Hope this video helps you with understanding proportionality and finding the constant of proportionality in tables, graphs, and equations.